Hello everyone, thanks for joining us. I'm Laura and I'm happy to present to you today about our Colorado oil and gas air quality analysis project at FracTacker. First, I'd like to introduce FracTacker to you. FracTacker Aliens is a nonprofit organization who shares data, analysis, maps, and other visual tools related to oil and gas industry. Its mission is to help the concerned public better understand the circumstance, as well as help researchers and public officials make better decisions about the world's energy future. The background of our project is that FracTacker has an app where users report oil and gas development as well as complaints related to the oil and gas industry. We want to get this information to the government regulators who can influence the development, and we also want to provide relevant data to the users of the app. First, we built an additional app that sends complaints to the COGCC, which is the main regulator in Colorado, and provides users with EPA data on the air quality at the time of their complaint and any facility nearby who has failed regulatory tests. Before we dive deeply into details, I'd like to show you an overview of how data flows through our pipeline in this project. We combine air quality data with complaints, run some analytics, generate reports, then we send those reports one to the government and one back to the user who made the complaint. Although we already have 10 sensor points and a lot of sensor monitoring data, it's obvious that we can't have data for all specific location and time. Our first idea is to use a model called high-split to simulate the dispersion of pollutant in the area. Thus, we can get the continuous distribution of pollutant and estimate air quality at any specific point, as you can see on the right. For high-split, we successfully got familiar with the model and generated simulations using bash scripts to run the high-split software. But as we dive deeper into the model, we find the accurate simulation depends on a lot of input data, and we don't have data source for some of them like radiation, turbulence of atmosphere, and decomposition rate. Therefore, it's hard for us to use high-split now, and we finally decided to give up simulation and just use the nearest sensor monitoring data. The techniques we used in our project now are here. Our data sources are AirNow and US EPA. Our app is mainly developed in Python. We use Pillow, Google Map API, and Matplotlib to generate report contents. Then use Jinja and PDFKit to format our report. And finally, use SendGrid to send emails. For usability, we developed a graphical user interface using Flask and wrapped up our app in a Docker container to make sure it can run on any computer. Here's how to use our app. The user can upload a CSV file of complaint records. Each record includes this information. Then our app will automatically generate report and send the 2 emails for each record. Then my teammate will introduce more details about content of our email and report.
Thanks, Laura. And now let's turn to the functionality of sending emails with report. But before digging into the framework, it's important to know what information to include for the best interest of each recipient. For the user side, the basic information would be various air quality measures of the pollutant. And we suppose that showing the nearby air quality data on a map and plotting the variations of the pollutant concentration in the past week would be helpful. We also find knowing the nearby facilities which may have impact on the issues will help the users to understand the situations around. For the COGCC side, as it is unable to receive any attachment for them, we want to include all the necessary information in the email body to file the complaint for users. And there are 3 key elements, which are the description of the issue people complain, the location of reported issues, and how can COGCC follow up the issues. Firstly, let's dive into the pipeline we use to send text email to COGCC. We start at the FracTacker application, where they provided us with a CSV file of the user information, location, and time of the report. By developing Python scripts using the geocoding API, we could get the nearest city and address giving the coordinates, and then insert the data into the formatted email body and send the email to COGCC using SendGrid. And here is how the email looks like using anonymous data. We address the what element by inserting the title and description of the report user provided. We further include the location and time of complaint, as well as nearest city and address information. And next, we can dig into a more complicated pipeline to send the email with report to the users. The first branch produces pollutant-related data. It takes the latitude, longitude, and time as input into the AirNow API, where we could get the concentration and AQI raw data. By performing some feature engineering work, the data of nearest monitoring site could be returned. And we also plot the graphs of pollutant concentration in the past week using Matplotlib. The second branch deals with the AQI map and the facility data. Similarly, they take the location and the time of the report as input into corresponding APIs. And after some data analytics work, the visualizations of nearby facilities and nearby AQI map is returned. And lastly, all these elements are rendered into the Jinja templates as variables inside. After having the formatted HTML, we could convert them into pollutant report in PDF and send it to FracTacker users using SendGrid. And here is how the email to the users look like. The text is quite similar to the COGCC one. And specifically, we will take a deeper look at the pollutant report. The first part is Air Quality Index Map, which is built by API requests from EPA rather than simulated by HiSplit. The map shows the real-time AQI data near the reported location within the radius of 4 miles. And the AQI appeared in the map as a composite AQI calculated with the EPA standard. For example, the AQI map on the right shows there are 3 nearby sites of different AQI within our search radius. And for the second part, we'd like to share the detailed information of the air quality measures for each pollutant. As you can see, the text includes the color pollutant concentration, column pollutant scores, as well as its AQI category, which represents the level of concern and ranges from good to hazardous. And notably, the color also corresponds to the AQI level. And besides, we also provide the users with the monitoring site locations with its distance and relative direction from the reported location for the user's reference. And the third element is the time series plot for the pollution concentration in the past week for ozone and PM2.5 separately. By looking at the variations, the users could have a better understanding of the air quality near the reported location. As we could find that there are some prominent peaks and fluctuations in the graphs, which may provide potential evidence for the pollutant reported issues.
So in addition to features Tian just mentioned, we will also present a satellite image and a table at the end of our report describing the facilities that are in a state of violation. As users, after seeing unusual black smoke or smelling a pungent odor, we will want to know which facilities have caused us the discomfort. As for the government, this information will help them understand the facilities currently in violation may not be correcting their illegal production behavior. We mark the user's location with a red icon and the facilities with abnormal status using blue icons. There could be over 2,000 facilities within a 3-mile radius of a user, so it would be pointless to give users the information about all the facilities. Users and the government may be more concerned about which facilities within 3 miles have a history of violation in the past or present. While it may appear that these facilities are the cause of users' complaints, there is actually no direct causal link between them. This is something we need to be especially careful about. Below the satellite map of the facilities, we will provide a table. In this table, we will provide some useful information, including the name of the facility, the street it is located, and its current status. You can see that the numbers in the blue icons on the left correspond to the facility serial numbers in the table on the right. So this will help the user to get a basic picture of the surrounding facilities that are in the state of violation. In the above, we have described many functionalities implemented in our project. All of our efforts over the past few months have been aimed at making some meaningful changes. There are about 5.7 million people in Colorado. We hope that with our efforts, a large number of them will understand the environment they live in and how it may affect their health. We believe the FracTacker team will better understand and analyze users' complaints about the environment and what is happening around their users. We also believe the government can identify which facilities cause problems to users in a shorter period of time so as to solve environmental problems more efficiently. In the near future, we hope our project will continue to be extended. First, we can add more meteorological data and then use high speed to provide users with a diffusion trend of pollutants. Second, we hope to integrate our application into FracTacker app and provide users with reports in the form of email. Third, more timely reports could be sent through the development of an interface for real-time transmission of users' complaints. As the functionalities continue to improve, FracTacker is sure to become a more data-driven application that will continue to contribute to our environment. The people in Colorado will surely become more concerned about the environmental protection, the environment of Colorado, and the health of their loved ones. Finally, we would like to thank the 11th Hour Project for supporting the launch of our project. We would also like to thank FracTacker team for all the help you have provided over the past few months, which has made it possible for us to achieve our common goal. We firmly believe our joint efforts will truly improve the local government, help people in Colorado, and promote the cause of environmental protection in the United States. Thank you all.